Okay, let's get into this. Today's deep dive is all about a really big broadcasting problem.
The huge one.
Yeah, how do you move just enormous amounts of high-quality video all at once over these huge distances without, I don't know, laying miles and miles of copper cable?
And that used to be the only way, right? It was a logistical nightmare. If you wanted 16 separate, pristine video signals, maybe even 4K, you were looking at literally thousands of heavy, bulky BNC cables.
So the answer we're unpacking is this piece of kit, the Thor Broadcast F-16SDI-3G-TXRX.
The ultimate shortcut.
And what's so wild is the footprint. It takes that impossible problem and just shrinks the solution down.
Right.
16 channels over one single optical fiber cable.
And the whole system, the transmitter and receiver, it fits in a tiny 1RU 19-inch rack unit, internal power supply, all of it. Just plug it in and go.
That density is just, it's all thanks to the core technology, right? Getting rid of the copper.
Exactly. It's all about 16-channel coarse wavelength division multiplexing. CWDM for short. That's the magic here.
Okay, but how? I mean, how are they physically packing 16 different video signals onto one tiny strand of glass without it all just turning into a mess?
So this is the really fascinating part. It's all about how they manipulate light. The key idea is that each SDI signal gets its own dedicated laser.
Its own laser.
Yep. And that laser converts the signal to a very specific optical wavelength. You can think of it as its own unique color of light.
Ah, okay, so they're not interfering with each other.
They can't, because all 16 colors are traveling independently down that single fiber. You can stack them all together and then, pull them apart perfectly on the other end.
That all sounds great in theory, but, the professional world, reliability is everything. How do you guarantee the integrity of that signal after it's traveled 120 kilometers?
Oh, absolutely. You're right to ask that. The device is fully compliant with all the crucial industry standards, like SMPTE and DVB-ASI.
So it plays nice with other gear.
It has to. And to make sure the quality is there, they equalize and reclock every single signal before it even hits the fiber.
So it starts out ultra clean.
Exactly. That reclocking is vital because the resolutions we're pushing here are, they're pretty intense.
We're talking 3G SDI at a minimum, right?
Yeah.
So 1080p at 60 frames a second.
And all the way up to 4K UHD, even at 60 fps.
But here's where the engineering gets really clever.
Okay.
If it's a 16-channel system, why do the specs say you need 4 of those channels just for one 4K signal at 60 frames?
Right. That's the data trick. You have to dedicate 4 of those 3G SDI lines and sort of bond them together.
To handle the massive data rate.
Exactly. For uncompressed 4K at 60, you need 4 lines. If you drop to 30 frames per second, you only need 2. It's a really elegant way to handle a huge data payload.
And you'd think with all that complexity, your range would take a big hit, but it doesn't.
Not at all. We're talking options for 40, 80, even up to 120 kilometers. That's just an incredible distance for uncompressed video.
They pull that off with a really robust optical link budget up to 35 dB. So for the engineers actually using this on site, there's another feature that seems essential, this SDI loop out on the transmitter. Why is that so critical?
That is your sanity check. It lets you monitor the signal quality right there at the source before you send it 120 kilometers away.
So you're not guessing where a problem is?
You're not guessing. It saves hours of troubleshooting. It's a must-have.
And that functionality is mirrored on the receiver side too, isn't it? Giving you dual outputs for every input.
Exactly. Every single SDI input on the transmitter side gives you 2 independent outputs on the receiver side.
Which gives you options for monitoring, for redundancy, anything.
Total flexibility.
So when you put it all together and you see the price tag, which is around, what, $15,000? It really shows you something. This is how modern broadcasting solves these impossible problems of just sheer data density and distance.
And that leaves you, the listener, with a really interesting thought. If wavelength division multiplexing allows 16 high data rate channels to share one tiny hair-thin fiber, think about scaling that exact same idea outside of broadcasting. Think about massive data centers connecting across a city, or hospitals sending huge, complex medical scans to specialists miles away. This light-based density is the future, everywhere.